when we have full control of that, then we bring in outside air through an ERV, an energy recovery ventilator. And then we have full control of the quality and quantity of air coming in and out. And so that helps us with moisture. It helps us with pollutants and things like that.
Hello and welcome to the Building Science Poddie, where we talk about better buildings to live and breathe in. My name is Jess Kismet and I am your host. In today's episode, we are joined by Chris Laumer-Giddens, the co-founder of LG² in Atlanta, Georgia in the US. Chris is an architect who thinks like a mechanical engineer. He's also a building science specialist who doesn't compromise on aesthetics. He does new homes and historic renovations, and he truly understands how buildings work and thoroughly applies what he knows to every project. Through his work in timeless residential design and his boots-on-the-ground technical consulting, he expertly bridges the gap between the architect and the builder and has become a leading voice in building better. Hi, Chris.
Hey, Jess. So good to be here.
Awesome. So first thing I want to get into is I want to know about your zero leakage house. How did you do it?
Everybody wants to know that one.
Tell us everything. Tell us about the construction. I want to know the climate was in, the client, was it the client driving this requirement? Was it by accident? How did you get there?
Well, first of all, I'm kind of a freak about it, I guess. I'm a control freak in that sense. In my regular life, I'm not so much, but in this, because I care about the clients and what they're investing in. So we have to have full control of everything. And so we've been not chasing it like just a number, but we are chasing zero leakage because we want to have full control of what's coming in and out of the house. And we can do that with zero air leakage. We've had 0.05 ACH50, we've had 0.04, 0.09, and as we get closer and closer to that zero, we're learning from each previous time, obviously, what we did differently. So the reason we do it is when we have full control of that, then we bring in outside air through an ERV, an energy recovery ventilator. And then we have full control of the quality and quantity of air coming in and out. And so that helps us with moisture. It helps us with pollutants and things like that. So how we did it is, we use a fluid applied membrane, a house wrap or water resistant barrier. And it has a lot of forgiveness for the installer. And we use a painter for this. And the first couple of times we did it, we wrapped the whole house. We have plywood sheathing, and we wrapped the whole house in this WRB. And then the roof has an underlayment, a peel and stick underlayment. And it doesn't always have the best airtightness. So what I found over time was that was where our biggest leakage was, in these 0.04 and 0.05 air leakage. And so what we did on this one is we took some of that liquid fluid applied membrane, the stuff that you put around penetrations, gaps, seams, and cracks, and we used that on the plywood seams on the roof before we put our underlayment. So we've got this perfect air control over all 6 sides of the building. And so on this project, we tested it with just plywood installed. So we didn't have the windows in, none of the rough in was done from the mechanicals. But this was our way of testing this WRB, because if we don't, then, and sort of stage it and we sequence these tests. So, okay, next test will be after rough in of all the mechanicals. After that, windows and doors. So we know progressively which of these components, which of these systems has the leakage. So the idea is, okay, now that we have those in, we know that our WRB is perfect. When the windows go in, we test and we have a failure, then we go around the windows and make sure they're perfect. And so
you've done like 3 or 4 tests on this project.
We will have done 3 or 4 before we do any insulation in the cavities, right? And so exterior insulation, and we have interior and cavity insulation. And this type of construction was asked for by the homeowner, but because this is the kind of construction that we do and design, right? So it's the type of buildings that we are familiar with and types that we approach. So these are the types of buildings we do. And so the homeowner found us, actually. So Matt Reisinger, you know who he is from Austin, Texas. I think he's been on your show.
Yep.
And so he's a friend of ours, and I've known him for probably 20 years. And when the owner reached out to Matt saying, "Hey, do you know anybody in Atlanta?" he referred them to us. And
Yeah, right.
it was an immediate connection. You know, we were like, yep, this is the right fit. You are doing the kind of construction that we want. And so this is a very cool project. It's a craftsman inspired design. And he said, you know what? Let's have some fun. Let's go ahead and get it certified passive house. And so that was his, you know, he was motivated to do that. And we use all of the software and go through the process the same way on every project, whether it's certified or not. So we use the WUFI Passive software, and and so we don't
You put it
necessarily
through the PHPP?
we actually don't use, so Passive House US doesn't use PHPP. We use a WUFI Passive software, but it's based on the PHPP. I mean, it's more user friendly, less tedious than the
Okay.
PHPP. If you go through parallel process, you get different results because PHPP measures, there are entries in there that you don't necessarily enter into WUFI Passive. And PHPP is used for Passive House Institute, which is the larger passive house organization. And then Passive House US was a branch off of that because we have so many different climate zones. So
Interesting. I didn't know that.
our passive house has, like, literally in the state of Georgia, you could have different targets between one city to the next. And so they've made it so climate specific that you go from these different weather stations. And if there isn't a weather station within a certain distance, you have to ask FIAS, which is Passive House US,
Yep.
ask them to generate the
To
weather
create
data.
you with a file. Yep. I mean, we have that here in Australia too. We have local climate data. I don't know if it's that specific, but we definitely have, the climate files for each location because we've got a lot of different climates here too.
Exactly. Yeah. So
Yeah.
this will be the first passive house in Georgia, certified passive house home in Georgia.
Mm-hmm.
And then I'm also working on another one in Tennessee that'll be the first, because the Southeast is a difficult climate. You can't just throw insulation at it like you can in the Northeast. You can't.
Yep.
We have so much humidity to deal with. We have to have a dehumidifier, and that takes energy, adds heat load or cooling load. And so it becomes a little tricky, and prescriptive path just makes your architecture weird because they want you to have
Yep.
these really deep overhangs that you just
Yep.
can't. There's no separation. You have to do it, So, so the owner was really driven by this whole process. And, for me, I want to deliver something that they've invested in, and I care about the results. I know that that's going to help us with mold control. It's going to help with indoor air quality. And frankly, we're speccing out these beautiful finishes, beautiful furniture, and I want to protect all that, so the outside in through cracks and gaps. It's like putting a really nice piece of furniture. This is kind of a parallel that I ask the owners to consider is take that furniture you have in your living room right now and just put it outside. Would you want to do that? It's not outdoor furniture, but over time you're exposing it to the elements like that. So that's one of the parallels we use, is to try to help them understand why this is important.
Yeah. I've seen not so much in South Australia, but particularly out where it's more humid in Australia, I've seen videos of just furniture going moldy. I know I've lived in Queensland, and our furniture and our shoes, our bags would go moldy because that humidity would just come into the house quite freely.
Yeah.
So yeah, I get that analogy. What stage is that project up to at the moment, and what was the latest blower door test result you've got for it?
We actually are just finishing up our rough-in, so we haven't done our second test.
Okay.
We have started to put insulation on the outside, so we have sealed up some of the penetrations, and the reason we're doing that is to help protect our water resistive barrier, because if it's exposed for longer than 90 days, it starts to degrade. So we've
So
put up.
you're protecting your water resistive barrier, your WRB, with your
Yeah,
external insulation.
that's right. Yeah.
That's the opposite of what we do here. We protect our insulation with our WRB. That's crazy.
Like it's like the layers. Yeah, yeah, yeah. We protect, and of course that WRB is protecting the cavity insulation, right? You know,
Yes.
it's
Yes.
protect the
So there's
protect.
2 layers. So take us through the wall construction of this
Okay.
project.
Yeah. So all wood frame. We're doing 2x6. I don't know how that translates to
I think that's equivalent to our 140 mil frames.
the
Hang on,
deeper.
6
Yeah, the deeper.
inches to 150. So that's slightly deeper than ours. We've got 90 mil frames
So,
and 140.
well, 140 actually is probably more accurate to ours because it's 5.5 inches.
Well,
It
that's the
used to
same
be.
then. Yeah.
Yeah, so it used to be a true 2x6, but over time, they would cut it and it would shrink in the drying process, so we lost a
Mhm.
half of an inch. So now that's a
Okay.
standard 3.5 and 5.5. So it's a 2x6 or 140 mil um, stud, and then half inch plywood, CDX plywood.
Mhm.
Whether water resistant barrier it's a STPE based fluid applied membrane, and it's just liquid house wrap. And
And
then
literally paint it on with like a roller or something
it's rolled
and a
on by a
paintbrush.
painter. Yeah. And I
Yep.
skipped a step that the cavities are filled with blown in stone wool insulation.
Mhm.
But okay, so back to the WRB. Outside of the WRB, we have 2 inches of stone wool, rigid stone wool insulation, and then a 3/4 inch layer that has furring strips that hold the insulation to the sheathing and to the structure. And then that is also the substrate for the lap siding. And we also have shingle siding on the second floor. And we have brick as a water table around the entire perimeter of the house, and then a brick tower for a brick stair tower. So those are 3 exterior materials outside of that, attached to that 1x4 cladding.
Mhm. Mhm.
And then we have drywall on the interior.
Mhm. Okay. It's a pretty heavy duty wall. Is that what you do for all of your projects? Is that your standard wall construction?
It's the sweet spot because
Yeah.
the what Joe calls the perfect wall is
Mhm.
basically the point at which you are controlling the temperature of the sheathing. So that we get a lot of there's a lot of confusion about the perfect wall. It looks like you're not supposed to have any cavity insulation because he puts all the layers to the outside. But those are your control layers. The insulation in the cavities, once you get the insulation correct on the outside, you've controlled the temperature of the sheathing to control the condensation and the moisture drive and all of that. Then the cavity insulation is bonus. It has nothing to do with the thermal control layer, if that
Mhm.
makes sense.
Mhm.
It does add thermal performance to the assembly, but it's not a part of the thermal control layer in that sense. So with 2 inches of insulation on the exterior and the 5.5 inches in the cavity, now we're at the sweet spot here in the southeast. And I think that would go wet, that we're doing it in a house in climate zone 4 also, which is one climate zone above us. We're climate zone 3. And it would work very well in climate zone 1 and 2, which is Florida. It would be more than they really need down there for the same level of performance in Florida. But it still would work really well. So anything below that, I try to stay away from. But
Mhm.
there are still ways to do, less insulation in the cavities, say, or maybe a little less on the exterior. You just have to, about 1.25 inches is about is about, that's what, 20, maybe
30.
30. So that's about as thin as I will go in this climate zone.
Okay. And if you were going further north, like where it's colder, would you just add more insulation on the outside? You would just beef that up? Is that what you would?
Yeah, I would find that sweet spot where I don't need the interior insulation to have thermal control, to have my control
Mm,
layer intact, and then
yeah.
go ahead and fill the cavities with more to give it a more robust assembly. Like, for
Hmm.
example, our roof on this project, we went a little beyond what we needed. You could actually do 2-inch because there's also a ratio in the code about exterior versus interior insulation that says your total insulation, whatever that is, you have to have a certain percentage of that has to be on the outside. So, so 2 inches will meet the code in Georgia. But we've gone to,
So your building code says you have to have external insulation.
sorry, the building code, if you're going to use continuous, the code says you
Right.
have to have a certain amount on the outside. So
Okay.
because we're using continuous, you could meet the code at 2 inches rather than 4, which is what we have.
Okay.
Yeah, our code doesn't have that requirement yet. It's an option to do 20 R20 to meet an R20 requirement. You can do 5 on the exterior and but it's not a requirement yet, but absolutely should be. Yeah.
Yeah. Yeah. And to convert the R values from the US to Australia, I believe it's approximately a factor of 5. So 20 divided by 5 is 4.
You're a
4.
you do
Is
you,
that
you
right?
okay, do you have R value or U value?
Oh, we have both, but insulation, we usually talk about R value.
Okay. I didn't know that you had a different R value for it.
We do. R30 Australian. Oh, it's giving me dollars. I don't want dollars. I'll work that out later, but I think it's a factor of 5. So that would be about R4,
Yeah. Okay. Yeah. So,
interestingly.
yeah.
Yeah.
So our code is, we still can, they allow R13 here in Georgia,
Yeah.
which is,
For the walls.
yeah, for just in the cavities. And that works out to be about an R10 when we factor in all the studs and everything else. All
Yeah.
the,
That's about what we have as well.
yeah. So it just seems,
Yeah.
of course we're having problems with energy, and,
Yeah.
that's why, this cavity gives us R23 because we're 24 inches on center. So 2 feet, that's the three, like 2/3 of a meter. I don't know. 3.28 feet to a
Gymnastics.
meter, I think is what it is.
Yeah.
So, because of that, we're at R23-ish. And then
Hmm.
we have the exterior at R8. So it's a pretty, it's about twice what the code requires.
Hmm.
The
Hmm.
continuous just helps so much because it's fully continuous. There's no
Yeah.
interruption
No studs.
from
Yeah.
framing. So
Hmm.
yeah,
Hmm.
both the wall and the roof are robust. Yeah.
Very. So
Yeah.
this WUFI Passive, let's just go back to that for a second. Is that because WUFI in Australia, the WUFI that we use is just a hygrothermal model where we model the mold index of a assembly. So is it additional if you WUFI Passive, has that got extra inputs in there?
Yeah, WUFI Passive, I
Or
mean,
is
it's the same software, right? It's same developer, but the
Mhm.
WUFI Passive is just one of the modules of the WUFI, and it focuses on energy, like
Okay.
energy, heating load, heating demand, cooling load, cooling demand, energy, number of kilowatts per person per year. That's one of the targets.
Okay.
So each house has a little bit different target based on its location, number of people, et cetera.
Mhm.
So that's what it puts out. And those are the metrics that the WUFI Passive says, okay, you pass or you don't pass. And you change those metrics by, reducing your heating and cooling loads so that the mechanical systems aren't running as long and they're not using as much energy, et cetera. You put LED lights throughout the whole house, those kinds of things. And so it's just doing that. You can switch over to the WUFI hydrothermic modeling, and we do that as well, but we use it mostly for on the passive side to understand our energy and the trade-offs. When we're not doing certified, we're using it primarily to show the owners what the trade-offs are for going with thicker insulation, or better windows, that sort of thing. But we're also using it as a tool for us to design, whether they care about it or not. We're trying to give them a better building that's going to last, comfort.
So is it a 3D model? Do you build a 3D model?
Yeah. Yeah, you do it in
Okay.
SketchUp first, and then you import it into
Yeah, same as
yeah,
same
yeah,
as PHPP.
Okay.
Interesting. Yeah. So you put in all of your
Yeah. Your location, your assemblies, all that get assigned in WUFI. And then, you can go back and forth with SketchUp.
and you still have to get the 0.6.
So it's a little, it's around there. Yeah. But it is based on the project. And I think ours was 0.5. It ended up being.
Mm-hmm.
They care more about CFM per square foot, and I think we're at 0.03 CFM per square foot or something.
Mm-hmm.
Actually, our results are 0.00. I don't know. It's all zeros.
That was the first blower door test that you did on this particular
Yeah.
project. That's what it was.
Yeah.
Yeah.
I think so. The actual result 0.018, but I, of course, looking around, I do this all the time when I do blower door tests because it's always the weak point. The failure point is you look around the blower door tent, the frame, there are gaps there. And we didn't use a fog test because they don't make a safe fog yet. So we stopped using them. So now but there's a huge gap where there's we use an old used door for this entry just to let people come in and out because we don't have our doors yet. So they put this old door in there, sealed around on the outside, but then where the door meets the frame, there's a hole in the frame. So all this air was leaking out there. I'm just saying that's why I call it zero air, because it wasn't the house that was leaking.
Yeah. Fair. You were betrayed by this old door.
Exactly, man.
Goodness.
Yeah.
Okay. So when is that project due to be finished? And when can we expect the final blower door test result?
Gosh, right now it's targeted for fall of this year. So I think probably late fall, maybe November, even December potentially. So I think that's when we'll see a blower door, a good final result. We'll have pre-drywall results as well. So when all the windows are in, all the penetrations have been made, and we've really sealed everything up, I think that's when we'll do our next blower door test.
Mm-hmm.
Yeah.
Okay. And we look forward to hearing about it.
Yeah, so do I. I'm ready to see the windows go in. They did things a little backwards here. They didn't put the windows in because they're still being shipped here right now. So it's usually we have the windows in by now, but the shipping and all. I mean, there were a lot of things going on. So the GC on this one, and I'm not the GC. There's a network. We helped hire a GC on this, and they just ordered it a little bit differently.
And that is one sort of caveat on the blower door test result, isn't it? Is that the windows aren't in yet because they are, particularly here, they are one of the, in airtight places, they are the leakage source, the windows.
Yeah, they can be. The windows themselves, the ones we're getting, these are European windows. And
which brand are they? Which
it's actually
manufacturer?
It's called Epoch Glass, EPOC, and they're a small company in Colorado. Okay. And they source everything from Europe. It's all fabricated there and brought over. But their tightness is, it's practically zero leakage. The frames are amazing. It's the lowest U value I've ever seen. Good glass from France. We're doing some steel windows as well that are all super tight. So what I tell people when they doubt us, or when they bring this up, Jess, I'm telling you, when Matt Reisinger came to the job, he did a little video and he talked about the project. He said, they got zero air leakage. And the video showed that there were no windows in there. And of course, the first thing people say is,
keyboard warriors came at you.
Yeah, it's yeah.
Yeah.
Of course you got zero. There are no windows or no penetrations in there. I said, well, but that's the point, and as I was saying before, the sort of staging it and saying, look, I'm checking this at this stage. And then when I do the rough in, that way I know I need to do better on my rough in penetrations. Let's go do that. Now, zero air leakage. Great. Now let's move on to the windows. So windows, when we put them in, we just attack the air sealing with the same rigor as we did the rest of the house. Why wouldn't we get a zero air leakage again? Right? Because you're applying the same techniques, the same attitude towards it all. So there's this, saying that, the windows are going to cause most of the leakage. I mean, that's not you saying that, but other people are telling us that. No, I don't believe that's not the just not it's not a foregone conclusion. It's not going to
Yeah.
happen.
Well, I guess it just is, perhaps not in your projects, but certainly in Australian projects and maybe other people's projects. That is what they've experienced. So you just got to
Yeah.
prove them all wrong.
Yeah. I mean, it's all possible. And I think that's the thing one of the reasons I talk about it so much and why I chase zero is I want to chase control. I want to chase not worrying, and
Huh.
the thing I try to tell this is the cheapest way. Getting a perfectly airtight house is the cheapest way to the highest performance, to the passive house, to whatever you're to the best performing house and the safest house that you can get. Because
Uh-huh.
I've never seen an air sealing budget go up to or beyond 1% of the construction. So it's so inexpensive. If you spend the extra time and the money on air sealing, it's going to save you in the end on so many things, from health to indoor air quality to salvaging all of your finishes and keeping everybody safe. It's just, so when people come to me with low construction budget and say, what's the one thing I can do? Be perfectly airtight. Your mechanical systems get cut in half from the code requirement, literally cut in half. You're safe. You're going to live longer. And it's all it
Uh-huh.
is air sealing. That's it. Forget about thermal. Forget about insulation. Give me super airtight. And then you've got a good building.
Noted.
Of course,
All right. So
you need to ventilate right. Of course.
yes, that's, of course, it goes without saying, although we do have to say it, don't we?
We do.
Yeah. All right, let's move on. I have another question. I saw on one of your posts that you have an actual implement that you use to measure solar radiation on your physical site. So in Australia, we model a house in Revit or SketchUp or whatever, and you can turn on the shadow diagram tool and it will tell you where the sun's going to be and where the shadows are going to be. But you've gone one step further than that and actually measuring the solar radiation on your physical site. So tell us about this tool.
Yeah. It's called a Solar Pathfinder, and it is a super fun tool to use and just like amazing when you see what it actually does. So it has a globe on it, and it's the, it's perfect globe. And so you set it on at basically where the house is going to be. If you can get it up to the roof, it's like the roof level where the solar panels might be. That's
Mhm.
useful. That's how the solar power folks like, because then what it does is it actually reflects all of the surroundings onto this globe. And that translates down to a diagram inside the circle that shows by the minute and by the hour and by the month where you're going to have where you're going to have obstructions. So then you can say, look, I'm going to have full production from this time during these hours of the day in this month. You can see the shadows or the outline of the trees or any obstructions that are around you. And that will
And it
inform.
draws a diagram. It physically draws you a picture.
Yeah. So what you do, you actually have to draw. So on the globe, you're looking down on top of it and you have a little white pen or pencil and you draw
Okay.
on the diagram where that is. And that tells you all of the hours of each month that you're going to be in shade. That even includes, it doesn't matter if the trees have leaves or not, because even the smallest shadow on a solar panel is going to reduce its production. Not a bunch, but as more and more twigs start casting shadows. So you have to account for all of that. So then we can actually put that into WUFI Passive, and all of that data put into WUFI Passive, and it will then use that to understand all of the solar exposure for the windows. So then it can more accurately tell us what our what our comfort levels are going to be inside, how much heat gain, how much heat loss. And it's the simplest tool. It's just a piece of plastic with a plastic globe on it. And then you have these little charts that you draw that little white line on, and then you kind of and you just get a stack of those charts, diagrams, and boom, next one. So it's a really useful tool. And now we know. So what that helped me do on the current project is we have the house is at at an angle, almost a 45-degree angle to the north-south. And because the master suite or the main suite of the house is facing southwest, but not fully southwest. It's not a full 45 degrees. It's a little bit closer to north than it is. It's more north than it is southwest, right? But still southwest. But what I could do was with that Pathfinder, I could see where the trees were going to cast shadows onto the building, or to know where they were at a certain time of day on the hottest days of the year. So I was able to change the solar heat gain coefficient on the windows in the main bedroom, the owner's suite, and all the kids' bedrooms on that side of the house to be lower, to then take advantage of the winter gain rather than worry about the solar gain, because I knew that the trees were going to help me at a certain time of day when it's the hottest, because my overhang is 2 feet, and I took advantage of that, but then it kept going. It started to fill in those windows with sun, but then the trees were there. They could then say, all right, we're going to take over now. And the trees were so thick out there that, like I said, we love our trees in Atlanta, but because it was such a dense area of trees, that all of that made into almost a solid, like there's some little filtering light coming through, but not real solar radiation in the winter. But in the summer, they're all deciduous trees, so we had full shade. So there's this tiny window of sun when they're not in there. They're not in the bedroom. So it's not going to be discomfort. It's not going to change the cooling load dramatically. It's just going to be for a small period of time. So that helps us understand, like, okay, now we can really gain from a lower solar heat gain coefficient, even though it faces a direction that most people think, never use a low solar heat gain facing southwest. It's going to be friggin' hot there, right? So that kind of minutia that's what we do, right? So we care about tiny little thing.
I love it. So in WUFI Passive, do you model the house as one whole building, or is it zone by zone?
It's one building. Yeah.
Okay. So you're just focusing on the individual windows, the performance of each window, and you can actually tell what that's going to be when you put in this solar radiation data.
That's right. Yeah. Well, it's almost, it's like just knowing. So what's interesting is when you change, also interesting, so many
things.
Yeah. So when you change the solar heat gain coefficient, the actual energy, this is something I learned when I started using WUFI years ago, is that it takes the average for the whole year, like the amount of kilowatts for the whole year. So what it's saying is if you don't let the sun in the winter to help with the heating loads, you go with a super low solar heat gain coefficient, which you'd think, oh yeah, that's a good idea. Except when you do that, your cooling load goes down, but your heating load is actually higher, or it's costing you more for long because of the trees are empty and that sort of thing. So by decreasing it, the total load for the year is less, and those are the targets. And I've actually used that to help me pass a project, because I was like, oh, let me just lower the solar heat gain coefficient. Boom, I got into the green because but you also have to factor in another layer, and that is comfort. So WUFI Passive also tells you about how comfortable people are going to be inside the house. And so we have to also pay attention to that. So we change the metrics there to see, okay, are people still going to be in that little happy spot of comfort? And so, this architecture was already complicated, right? All my layers, and then, you're
Chris is like, let's make it even more complicated. It's time for a quick sponsor shout out. Today's episode of the Building Science Poddie is proudly brought to you by our amazing sponsors, Enduro Builders and Climasure. A huge thank you to these incredible businesses for supporting the podcast and helping us spread the word about better buildings to live and breathe in. Your support makes this podcast possible. Please head over to their websites and follow their social pages.
I just can't get enough. Yeah.
It's incredible. Like we put, in our PHPP models, we model the trees. We download a digital tree and we put it on the site because that's approximately where a tree is going to be. That's how many there are. That's how dense the leaves are. And not Chris, you want to know actually what's going on.
I gotta know more. And
You got to know.
we actually do the same thing. What FIAS has recommended is basically you create another object out in the distance of what represents all the trees.
Mm-hmm.
So I put that in for the modeling because that's when they do their quality assurance, they have to have that object in there. But of course, I've
Yeah.
already checked to see what I leave that off and I create the actual, and they're pretty close. And I'm like,
Yeah.
change the height of the wall to get as close to what represents what I put in there from the Pathfinder. So it
Yeah.
just helps. It helps to have a check, a pressure check.
Mm-hmm. Mm-hmm.
Yeah.
Yeah, for sure.
Yeah.
Good on you.
Well,
All right. So
can't-
something else interesting that I've seen you do, you're doing all these different things, stuff that we wouldn't even think of in Australia, and I'm sure in America you're way ahead of the game as well. Something else you did was I think it was a concrete slab without footings, or it was completely separated from the footings. Tell us about this concrete slab.
Yeah. Well, I like I was saying earlier about air sealing. There is a simple way to achieve this performance level, this durability level by just going full on air seal everything perfectly, right? And
Mm-hmm.
in the same vein, I'm looking for ways to simplify this type of construction, this type of design, because we get a lot of pushback from builders, architects, from homeowners and things that things are just so complicated to get this type of building enclosure or this type of home. And so I've for years been working on how do I simplify these structures. And I found the sweet spot with this wall assembly, and it's a very simple way to build an assembly. Every builder I talk to, oh yeah, that's straightforward. 2x6 is easy, is we do that. 2x6 at 24 on center. We fill the cavities with the insulation. I get it. That's easy. And the 2 inches on the outside, not a big deal. It's like stacking up boards, and it gets attached pretty simply. So then we go at like monopoly framing. I don't know if you've heard of this term, or Catan framing that Matt Reisinger sort of coined. He called monopoly framing. And the idea is simplify the wall to roof. Well, Matt just put the name to it, just like Joe Stiebrick put the name to the perfect wall. He's not the first one to do it. We've all been doing similar things. And what we're doing is we're not building the rafter tails into the framing structure, the structure of the building. We're attaching them after the fact so that we have simple connection between the wall and the roof. And then by attaching them on the outside, well, there's no thermal bridging, there's no penetrations with the framing. Well, taking that logic to the slab to wall. So we're doing kind of a monopoly slab because and this, by the way, that's before we get into the details of this works in climate zones where your frost depth is about 12 inches. So that's 1 foot in imperial. So whatever that is. So to make that connection, and I want to keep those layers, like my thermal control layer that's on the outside, I want to easily transition to it going this way. So what's the one thing that makes it complicated? Well, going into the ground with a footing, and under that footing has to be a high compressive strength insulation, and that's usually a foam board, and I don't use foam on our projects. And so I'm using all stone wool. And so how do I get this to work so that I can use stone wool? Well, they allow stone wool underneath the slab in the middle, but not underneath these point loads because it doesn't have the compressive strength. So I just said, well, what if we just knock off these footers, knock off anything that's creating a depression in the ground or create this origami that I have to run the insulation around, and just say, well, let's just thicken the slab, make it one gigantic beam or one gigantic thing, I guess. But it's a floating slab. It's a raft slab. And it is a detail that's been used. Raft slabs usually are a lot thicker. They use them a lot. They use them in California to help with earthquakes. so they can all move at the same time. But this was to be able to get all of my control layers perfectly continuous. And we have so that's the idea behind it, is to simplify it. So we have an 8-inch thick slab sitting on top of our vapor barrier, and then 2 inches of stone wool insulation that's on top of a filter fabric, because we don't want any dust from the gravel getting, kind of working its way up. Actually, the filter fabric is underneath the gravel for containment to keep the dirt out of the gravel, so we don't, for the radon system. But we have 8 inches of gravel and then this filter fabric. And that sits on our compacted fill. But what we did is, because we have a brick water table, is we ran an 8-inch by 12-inch, about that big, 8-inch by 12-inch concrete footing all the way around the building that's going to hold our water table. And that's separated by that 2 inches of insulation. That footing also worked as our containment for the gravel. So it told the contractor where the top of the gravel, where to put it, where to set it. It's called a screed. Said, okay, you go to the top of that footer, and it gave it a perimeter so it didn't mush out, right? So it was just perfect flat. So there's a physical separation between that footing and the slab of 2 inches, because it's not part of the same system. That footing is not supporting the house. It's only supporting that 3-foot water table that we have. So it's a 1 meter. So that I could have that footing or not, but what it does do is helps contain the footing. So it's very simple, and it went in so fast. The gravel went in because the footing was there. They said, like, okay, fill the tub, level it off, no problem. The vapor barrier, super easy, just a completely flat surface. 2 inches of stone wool insulation, perfectly flat. All I got to do is butt the joints, done. Then I have to do form boards for the concrete, and one flat thing. None of this dips. All the rebar went in so fast and so easy. Like they didn't have to bend anything. It's so much of it just simplifies the way we can build a house. And there are ways to do this in colder climates. You have to do thicker insulation. You probably have to use EPS or some other kind of foam board insulation. They do it up in the colder climates. They'll use these huge raft slabs, and their insulation layer, Jess, is like 3 feet, like 1 meter thick, or thick.
Underneath their slab.
Yeah. It's gigantic pieces of EPS. And it creates the form for the slab, and then it creates this kind of bowl, and they just fill that up with rebar and concrete, and that is your foundation. And it sits, and it's been working. They've been doing that for a while. So it's kind of the same idea as that, but for a southern climate, and not using any foam.
I know you don't like foam. That's one of my questions.
I just say we don't need it.
Yeah. Well, we use foam under slab insulation here in Australia. And when I saw that you use stone wool under your slab, I was very interested. So it's interesting to hear you talk about it. Did you have to get like a really sort of brave engineer to take all this on with you? Or was it easy, or?
We had 2 engineers. We have 2 engineers in Atlanta that we work with. And the one that we worked with the most, we met him when we first moved into Atlanta at some event. We're brand new here, and it was great. We hit it off, and we've been using him ever since. And he got busy, so we started using another one. And engineers by nature are conservative. And so our friend Brendan, the guy we really like, he's willing to take more risks. And so I called him about this just concept. I said, what do you think about this? He actually got really excited about it. He's like, man, this is perfect. This is like amazing. Like, he loves the idea, and he helped me get through some of the preliminary ideas and concept. And then I said, well, we're going to have to use somebody else because you're too busy. So we went to this other one. I'll just speed up to the end of this. I heard through the grapevine, and that's just from the general contractor who hired him to come out and do some inspections. He said, I only did this because Chris told me to. He made sure it worked. Like he didn't just sign off on a design that was going to fail. He was just like, I just don't like it. He didn't like the idea of it. And so we had very different, at least he did it, But he he did he did the first version. He had one with helical piles in it. So he was drilling these piles into the ground. And I said, look, can we get rid of those? I don't want any penetration. So we rearranged the framing and redesigned the house just a little bit. And we got it to work where we didn't need any of that. So he was good in that sense. He'll was like, whatever you want me to do, I'll do it. You tell me, it's like, but he wasn't as eager and he wasn't as accepting of the concept. But he did the first one. So that's cool, and the contractors love it. A couple engineers I've worked with, they love the idea. So for the simplicity, it's like a clean desk, clean slate. It helps my brain be calm and happy.
So do you do that for all of your projects now, or is that for just one particular one that needed something a bit different?
I do it where I can. I do propose that so we're about to start a project we've started a project in Florida. This one's going to be more hurricane proof. So we got a lot of concrete and masonry, and it's going to be the shell is all concrete basically. But we'll do a floating slab inside the concrete shell. So that slab will be about 6 to 8 inches thick, but we'll have that insulation on the edges because Florida, we may not need anything underneath. So, but I actually like it down there. It helps keeps the slab stable. It does keep the slab at the same condition as inside. So there's even in the summer, yes, it helps with cooling, but it then gives you cold feet when the rest of the house, so it can potentially, because it could be 50, 60 degrees down there and your air temperature is in the low 70s, mid 70s. Yes, that helps with cooling, but if you want to walk around barefoot, that's that conductive heat transfer. So it's pulling from your feet. So if it stays the same temperature as the indoor temperature, then you're comfortable on all parts of your body.
And for anyone listening who's having trouble visualizing all of this stuff that we're talking about with the perfectly airtight house and the floating slab and everything, I'm going to put links in the show notes. So please go visit the show notes so that you can actually see Chris's posts. We'll have some details, some images, some videos. I'll see if I can get all that from you, Chris, so that we can actually show people what you're doing, because it's really, really cool.
Thank you. It's been years of trying different things, but we're always refining it to be to make sense to people. So
while we're on slabs, there was a post that you made about how to build a concrete slab that lasts forever. So how do we do that?
Build and avoid. Don't let humans touch it. No, this again, having full control of all of the things that will deteriorate a slab. You have to start with a good soil base. Right? You can't the slab by itself is no good if the soil is no good, right? So it has to be on a solid base, and you build up your layers. And this system that we did here is one that can last forever, in that it's contained, it's dry, it's going to stay dry. It's done drying by the time the owners move in. We've protected it from the vapor coming below to then, because what can destroy a slab is rust, corrosion on the rebar. So as long as we're not letting the moisture in, so the connection of that slab to the earth, and not going necessarily to the code minimum of PSI, and is one way to do it. Then we also have control joints where they belong, so we know exactly where we're going to have cracks when it cracks, because I don't know if you know this one, but we have 2 types of concrete. Do you know the 2 types? Do they have that same?
Not sure. Tell us.
One is the type that's going to crack, or that has already cracked, and the other one that's going to crack.
Oh, I see. Yeah.
Yeah.
Kind of like windows that, haven't leaked and will leak.
That's right.
So failure is inevitable.
It's true. And cladding, that's why we put rain screens, because the siding will leak. There'll be a leak somewhere. So we have to give it forgiveness. And so that's the thing with slabs too. We have to give forgiveness to the slab, allow it to crack if it needs to move. but we've designated where that's going to be. Fewer transitions, fewer turns, like this slab is just one solid piece. Having that turn down is a corner. And in passive house, in terms of energy performance and heat loss and heat gain, corners are big failure points because they usually have a lot of framing there, and it's usually where leaks happen. So they try to minimize the number of corners. Same thing with a slab. You minimize transitions, turns, then you're going to minimize the failure points. So designate the failure points. Don't give it a chance to just fail where it wants to or when it wants to, but also just that connection to the earth, and really just build from the ground up to say, okay, I've got all my layers are in place. We've controlled all the water. We've controlled the movement of soil by compacting that earth to 98% to 100% compaction rate, which means just almost solid. So we're controlling that. And then the gravel has to be perfectly packed well, and getting your good vapor barrier in place and sealing it well. So, I mean, there are other ways to do it. The formula for your concrete has to be the right mix, so you don't want it to dry too fast, and you don't want it to spend too much time with water on the surface, because that creates surface cracking. So getting the right mix at the plant, so I do that a lot too. I put that in the drawing sometimes. I'll say, this is the mix. I want this ratio of water to concrete. And so then I know that that's going to be the right slump, because you don't want to have too much or too little slump. And so then I'm also there when the truck shows up with the concrete. Even as an architect and not the GC, I'm always there when the concrete shows up to make sure the PSI is correct, make sure the slump is correct. I do a slump test. We do core samples and to make sure that it reaches strength. Usually it's reached strength within 3 days, which is because of our design, because of our recipe. So from recipe to soil, everything in between, getting all that to where everything works and is designed around all of the failure points, and eliminate those failure points. That's how it's going to last forever. I mean, forever is sometimes relative, right? Forever for us is till we die.
Yeah. I mean, concrete's pretty resilient as a general property of the material, but it does and can and does fail, crack, go moldy, all those sorts of things. How long do you leave your slabs to cure before you build on them?
So we had, for a while, there was a product that it was basically a vapor barrier that we put on top of the slab as a floor protection. So it would help us, because the slab we did this first one we did this on was actually going to be the finished floor. So we wanted to really protect it from scratches and stains. But this product is vapor barrier floor protection. What it did is, after the pour, we put it on like within 12 hours, and it kept the moisture in the slab longer. So the longer the water stays in the slab, the longer it has to cure and the stronger it becomes. So if as long as you can really control that moisture with this vapor barrier that's sealed to the edges, then you've really preserved the strength of that concrete. If you don't have that vapor barrier, I want at least 2 weeks before we start framing. And I know that there are schedule restraints and things, but it's all part of the planning, that a minimum of 2 weeks, preferably 4 to 8 weeks. I want that stuff to really cure. Now, our core samples tell us that we reached full strength within 3 or 4 days. So at that point, it's ready to build on, right? I mean, that's what so I still like to have that slab, just let it be, let it rest, let it settle in. Because when you start putting all this weight on it, it's really starting to change the dynamic with the gravel and the insulation. It's risky to go immediately, but I think 2 weeks is the absolute minimum.
Core samples. So do you core sample all of your slabs?
I shouldn't call them core samples. They're core cylinders. When the concrete comes in, we'll pour the concrete into these little cylinders, and they take them to a lab, and they they test them at 7 days and I mean, at intervals up to 28 days.
Huh.
Well, they did a 3-day check, and that's when they determined that we were above strength. We were already above
Okay.
our minimum strength. And again, that's due to the recipe and the right timing and making sure we don't, having the right slump and making sure we don't leave water on the surface, et cetera. And that
Mm-hmm.
allowed us to reach that strength so quickly.
Can you test your moisture content using that sample as well?
No, that's a good question. I think yes, they do. They can do that with a sample of the concrete. We don't actually, I think that comes in with the slump, with the mix, and because the water to cement ratio does determine our slump, it helps
Mm-hmm.
determine and so that is, what, we don't test that one. Yes.
Mm-hmm. Mm-hmm.
Specification that we give them, and we know that comes because our slump is correct,
Mm-hmm.
but, yeah, we don't.
Okay, so you're a special breed of architect. You're not just sitting behind a desk drawing pictures, pretty pictures, and saying build this. You are so hands-on. And not only are you hands-on on site, refining your details, going to the absolute nth degree to make sure that what is designed gets built. You also design your own HVAC systems, your own air conditioning systems. So, this you're an incredibly comprehensive construction professional. So how did that come about? Did you go to uni just to do that as well, or college, or how did that come about?
The really short answer is the economic downturn of 2008 was how that
Yep.
happened.
Okay.
So we were in Florida in 2008. We're living there, and it hit Florida hard early in
Mm-hmm.
that downturn. Atlanta, Georgia was still going strong for a little while. So I was able to pick up a job here. Was let go down there like everybody else. And so
Mm-hmm.
I had 4 job offers up here in Atlanta. I mean, that's like the first time in my career. And I worked with a company that did high-end restaurant design because it was just a fun job. And then the economy thing happened, caught up to Atlanta. And so 9 months in, I was the last man in, and I was going to have to be the first one to go.
Mm-hmm.
So I then was on job hunt for 6 months. So I was unemployed, but every day was was working. I was working my tail off to get out there. So I met a guy called Allison Bales, and he's a building physics he's a physics retired physics professor, and
I've
got
also
in.
got an episode with him coming up, by the way.
Okay, good. Good. Yeah, so anyway, he got into building science. He worked at an organization called South Face here in Atlanta. And that taught him a lot about building science. He built his own home, and then he started his own company doing building science education, and he wanted to start doing HVAC design. Well, I came along, we met at some green building event, and he was like, "Look, I need someone to do that." And I was like, "Well, I don't have anything else to do." So he gave me this job, and he said, "You need to learn how to do HVAC design for houses." And there's not a degree for that. There's engineering, but it's usually for commercial. And there are
Commercial.
very few residential engineers for
Mm-hmm.
mechanicals. So I had to learn the software. I had to learn the protocol, deep dive into the protocol, the manual JST&D, which is what is American Air Conditioning Contractors of America have these 4 protocol. There are now other ones for high performance homes, et cetera, or low load homes. But so I dug deep into that. I learned the software, and I immersed myself in it. I found a great mentor across the country, and I spent hours on the phone with everybody that I could to really understand it. And I just started cranking out these load calculations and HVAC designs and became really good at it. And then we eventually got one design for architecture job when I was still working for Allison, and then another one came, and then all of a sudden it was time to join my wife's company, LG Squared. She started it in 2006. So I was like, well, I just kind of grew out of that position. It's time to join Jody and let's do houses together, because all of this, the building science, the HVAC, it's all super useful and people are asking for it and need it. And so we started incorporating it into our designs, but as a sort of side hustle or consulting or, when we didn't have architecture, I did a lot of HVAC design and I became kind of good at it, a specialist in it, because I took it to that level of HVAC architecture, where it's like full on plans. It's coordinated with the structure. It looks like a set of architectural drawings, and it's, they're pretty and they have all the information. And being so into the details as I am, I provided a lot of information. And so these are very comprehensive designs. So that's kind of where it all originated and grew into. And now, for the most part, we just incorporate it into our architectural projects. But I currently have, I think, three projects all over the Southeast, all over. I have 3 projects in the Southeast that are just HVAC design, and I do the plumbing design as well. I don't know.
Just another feather in your cap.
Well, it's important to integrate that because, you're locating all the ducts, and in our architectural projects, we locate the electrical. And so I wanted really, to learn the plumbing side of it, because that's a huge component of passive house, right? Is to, time to tap. And so if you know Gary Klein, he's the Joe Stiebrick of hot water.
Okay.
Yeah, he would be an incredible guest on your body, because
I've just written his name down.
And tell him I sent you. But he's so I worked with him years ago, and I brought him back into this project. And the way he does it is with me is he'll just show me how to do the design rather than, here, just give me your plans, I'll do it for you. So now, oh my God, I can't believe I know how to do this, but I calculate all the quantity of water in every single pipe. I know how to calculate time to tap, all of that. And whether it's copper K, copper L, copper M type of pipe, or PVC or PEX or whatever, it can change. And I go on to it's like I have all these different programs and websites open to know.
Do you have like 6 screens?
Yeah. Yeah. And I'm like, exactly.
Yeah.
And I'm just surrounded, like all these curved screens, right? I've got they're all just surrounding me, and I just kind of spin in my chair, right?
Like a spaceship.
Because my head's spinning, I might as well spin with it. But anyways, I get all the data, and then I place it in the building, and I, elegantly design the path for it. And I show these big sweeping bends, and the plumbers and the HVAC contractors, they look at these drawings and they're like, oh my God, this is the best thing that ever happened to me, because I don't have to figure out, and it all works because I also place all the framing, and I design each wood floor truss. So I know where the openings are. So I place the plumbing exactly where there's an opening, or the duct, and I create an opening in the truss for the duct specifically. And everything just fits where it's supposed to, because we control everything of the design. So it makes sense. I mean, I'm not saying that all architects should do this, but all architects should do this, because have full control of everything is what architects love. We love control, and so here we go. Let's control.
And it just minimizes the risk of error, doesn't it? Like, to practically nothing. If you're across every part of the project, the level of trust that your clients must have in you.
Well, that's a big reason why we got this job that we're working on right now, the one in Florida, because the owner knows that we understand every aspect of getting a house done. And so he's not only hiring us to design the buildings for this project, but then during construction, I'm going to be going to this site a lot to help him execute all of these details, because he knows that I can. He trusts that. So it's
Absolutely.
it's like a full life, or it could be lifelong, because he's going to do other projects as well. But it's the duration of the project and the continuity of that, the relief that people have of saying, look, I don't have to hand it over to someone else, and I hope everything gets built the way you designed it.
Communication. I hope they communicate with each other. It's all up here.
Exactly.
Do you have a massive life insurance policy? Because you're pretty valuable.
500 million. That's right. 500. Yeah. Yeah. No, we have a lot of conversations with our attorney because every time I add a new service, like
Yeah.
became a certified passive house consultant, started doing the HVAC system, HVAC design, plumbing design, and we have to
Yeah.
go to them each time and say, hey, do we need to bump up the insurance? Do we need to have separate insurance for that? I mean,
Yeah.
so, yes, and it's all up in here. I need some help,
Mm.
I'm getting to the point now where I need to have people helping me do these things, support. So we're working on that now.
How old are your kids? Are they going to come into the business one day, do you think?
51. I'm the only kid in this family.
Right.
Um, we actually don't have kids. We
Oh, I thought
adopt
you said kids' bedrooms earlier. Sorry.
maybe for the project, but
Right. Okay.
we do foster kittens though. We see
Oh,
probably
cute.
yeah, since we've been in Atlanta, we've probably fostered 300 kittens or more. Yeah.
Cute.
Yeah, it is the light of our I mean, it brings us so much joy. We have a little dog, Jasper. He's perfect.
Yeah.
He's an
Yeah.
ambassador for the kittens. So that's
Love
our
it.
family.
Right. Okay. Cool. So the clients that you work for, are they are they the rich ones? Because this is a very valuable service that you provide. Do you work for high end, like people with larger budgets? And do you have an offer? Like, if so, do you have, because I'm going to assume the answer to that is yes. You can correct me if I'm wrong. But do you have like an affordable version of what you do?
So we have
Or
like
not, this is probably the wrong word, but you know what I mean? Like
yeah, no,
a
I
less
know.
expensive version.
Right. No, it's really about value, and I mean, I don't want to sound like I'm avoiding the question. Some of our clients do have a lot of means to get what they want done, and
Mm-hmm.
they can ask for whatever they want, and they'll get what they want. And then there are clients who are they'll be kind of teetering on, oh, I really want to use you, but man, it's not that my rate is so expensive necessarily. It's just that
It's included.
well, it's relative to the project. They're like,
Yeah.
man, you bring so much value. We need everything that you can do. We don't want to ask you to reduce your rate. And of course, we're
Mm.
not going to offer that either. But
Mm-hmm.
I really want to, like, they want to go away, make some more money so they can afford us. Right. And they've done that
Mm-hmm.
before. But so, yeah, I mean, we have a client in North Carolina on the Instagram. You've seen him, the Red Wolf build. He's a DIY builder called Ron. He's amazing.
Mm-hmm.
He's and Demetrius, the two guys, they have been the best builders, the best clients ever. But, those guys came, like, he's building a little cabin. So there's not a huge budget there,
Mm-hmm.
and so he was, yes, on the verge. He was like, I really need I need your details. I helped him do the building enclosure details. I designed his mechanicals and plumbing. And so he was able to, he's like, okay, let me think about it. Let me think about it. And it's like, okay. And he was very tight about hours and everything. He says, look, when we were done, he was like, I can't afford to go beyond this. So it's got to be, we got to be wrapping this up. I can't afford anymore. But he was able to afford what he did. So
Mm-hmm.
it's not so much that we have an affordable rate. It's just our rate is what it is. And we work with them to say, okay, well, the scope can change. We can just do mechanicals for you, or we can just, do the building enclosure detailing if you want to do it that way. So, so there are different scales of it, but there's not really like a reduced anything, but
Mm-hmm.
this current client that we're doing and that we're working with in Florida, there's, they're the ones that they're getting what they want. And
Yep.
because they can, and
Because they can.
and we're going to be busy on that one. That's going to take up like all of our time for the next year. So like
Mm-hmm.
we haven't stopped working since we started, and through every weekend. And when we're in France, we're still going to be working.
Yep. France and the chateau. It's hard life. Chris has got an incredible chateau where is it in France?
Southwest France, about an hour and a half east of Bordeaux.
Yeah.
We don't
I'll
own,
put some photos.
yeah,
It's incredible.
we don't own the whole thing.
Yeah.
We do
Unfortunately.
have an amazing space in the chateau. It's one room. It used to be the grand ballroom. Yeah. It's a beautiful space.
Incredible. Incredible. So We've been talking a lot about marketing in Passive House in Australia at the moment. So is all of your work through word of mouth? How do you attract the clients that are going to be on board with what you offer?
It's social media, like we have to, so to get, well, social media brings the clients, and a lot of times they already come to us with all of, like, their wish list includes passive house, or we want a Joe Stebrick enclosure, or we want, I've read Joe Stebrick's books and I want a house that, uses his details and his systems and his
Hmm.
approach, or Matt Reisinger, for example. I mean, big influence in this country. And so when they watch Matt's videos, it leads them to us. So they
Hmm.
end up coming to the table with the desire to have this type of home. And so we don't necessarily sell them on anything.
Yeah, they've already got the idea of what they want and they know how to get it.
Yeah,
Yeah.
and even what most people call luxury clients, meaning, high-end finishes and really beautiful spaces and swimming pools and, just all the amazing views from inside to outside and all that.
Hmm.
What the high-end luxury people, even though those are coming to us and saying, we also want to have a healthy space environment. We want to have clean
Hmm.
materials. And I mean, this healthy home wave that's happening across the world right now is reaching into all levels of design, right?
Hmm.
And because you have some people who are in that high end level, and they're the ones that are becoming sick, and their kids are getting sick, so they become consultants, and so they're reaching out
Yes.
to other people at that level and saying, you need this in your home. Your $10 million home that you just bought is sick, it's full of
Mm.
mold, and so it's starting to reach in all levels. And so, yes,
Hmm.
we don't have to sell much. That's a
Yeah.
beauty kind of being educative, being educators and sharing this sort of thing, is that they already know that we've got what it takes, and that's
Yeah.
exactly what they're looking for. So it's, but if you had to sell it, it's more, we talk about comfort, we talk about air quality, we talk about, end of life, kind of, your life could be longer if you live in a home like this. You have full control. It's like, what if you walked around the ground floor of your house, and in every single room it was the exact same temperature? Have you ever experienced that? Or have you ever experienced not having ceiling fans on in every room because you're not getting cool enough from the air conditioning, or, you're sticky even though the AC is on? How would that feel for you? And so just talking about the benefits of it and saying, "Oh, I get it." And then it always comes down to, well, I just don't have the kind of money for that. Okay, well, let's talk about how we get there too, with just good
Hmm.
air sealing or things like that. So,
Yeah.
you know, there are selling things, and I think the one thing we have to sell the most is, because of all these tiers that we offer: architect, interior design, HVAC, plumbing, house, durability, timelessness,
Hmm.
constructability, construction, every layer of that, we stack all that. Well, they still see us as architect. And if they compare us to an architect who is just doing architecture, our fee looks like it's a little higher than theirs. But if you stack everything that you're going to end up spending with architect, interior designer that are separate, then you're paying this much. Whereas if you consolidate it into us, we're more like down here. So we might
Hmm.
higher, but we're not comparing. That's not a comparison, apples to apples comparison. It's very,
Absolutely.
so that's the selling that we sometimes have to do.
And you mentioned interior design. Your wife, Jody, is she in charge of that?
So she does. She
Yeah.
started the company doing only architecture, and we've incorporated interior design over the years because she's just
Hmm.
good. She's just good at it, and
Yeah.
she didn't do the formal training. So there are areas of interior design that like what interior designers do that she doesn't do, but she still
Hmm.
gets the job done. She
Hmm.
knows how to pick the right stuff. And the house that's under construction now, she did the whole thing on her own with the owner after designing the house with me. Like, we both worked on the house design. And
So you're both architects?
yes,
Yep.
yes. So she's architect first, but she's always
Hmm.
had a flair, really good with, I mean, these doors right here, these weren't original to the condo. And She found them in a warehouse, and we turned this corner of the condo into this French atelier, like just a nice little studio. People come in, and this is like their favorite space in the condo because it's beautiful. It's amazing. And so she has it, so, and now, yes, we're offering full service interior design separately or as part of the
Yep. What a team. Tell you what.
right. It's
Ah,
nice to not, like we're not big on the corporate world, so we bring in, where we need help, we do bring in some people just, selectively to handle certain things like drafting
mhm,
or, just production support and things like that. But
mhm.
yeah, we can do it all.
You wrote an article recently for the Bean Grilling. Oh my gosh, Jessica. Green Building Advisor, titled A Perfect Enclosure Aligning Continuity, Clarity, Durability, and Beauty, which was published in February of this year. What was the main message you were trying to send with this piece?
I think the continuity is probably the driving force of that because this article was about that slab that we talked about earlier, the
Huh?
this uninterrupted
The
slab.
magical slab?
Yeah, and so like that's a great system. The slab is beautiful and but when you start going up the wall, we have to make sure that all those layers, as we all know, continuity of control layers, and has to remain the same robustness, the same durability, all the way around the building, or else that slab is useless. So that slab is beautiful, it's great, it works wonderful, but if the walls and the roof are trash, it doesn't matter what we did down there. So the idea was, okay, this is a 3-part series. So the first one is about this slab. The second one is going to be about the window, how the walls meet the window, because this one is about the slab meeting the wall, right? So then we have wall meeting all of our openings. And the third part is going to be where the walls meet the roof. And the idea is, if we're going to do this, let's go all the way with it. Let's not just think that we've got a perfect wall and that the roof and the floor don't matter. That,
Uh-huh.
as Joe has said, the wall is the roof is the floor. The floor is the wall is the roof. It's all the same thing. So let's just take that perfect wall concept, turn it 90 degrees and make a floor, turn it another 90 degrees at the top and make a roof. And then, but the most important thing is if you have a failure in that connection and the continuity of that enclosure, you have a failure in the whole system. So the beauty aspect of that in the title is, I believe that a very important fifth control layer is aesthetics. Joe says ugliness is not sustainable. It's about, so Joe, right?
Yeah.
But it's that kind of thing. Like, of course, we're architects and we care about how beautiful buildings are. So we want that layer in there because they're not going to take care of it if it's ugly. We might have the perfect other 4 control layers. They might be perfect. It might last forever, but they're not, but there's still maintenance no matter how much. I mean, if you don't maintain it, you keep the systems at the right temperature and keep the systems going, clean the house, get the leaves out of the gutters if you have them. If you don't maintain those things, that's going to build up water in the gutters and it's going to leak into the house at some point because it's just going to back up.
Your chateau is the perfect example of that, right?
Saw that. Yes. Yeah.
I did see that.
That was a fun day. I mean, we were up on the roof and we had drone shots and I was still in America before we went over there. We heard about the leak and I saw these drone shots and I knew exactly where the problem was. From the drone shot, I saw the leaves piled up there. I said, but what they thought it was something happening inside the building is destroying our monumental stair. And so they were
Terrible.
thinking, well, where is it the window? Where is it coming from? And I saw from the roof, I said, it's got to be right there. Water is backing up and it went underneath the coping and then went down inside the wall and into the building. So
Mhm.
it hadn't been maintained for about 15 years because the building went condo about 25 years ago, and people weren't renting. People bought it to rent it, and so as condos, they would rent it out. but they weren't filling up. And so and then the owners of these investors they just stopped paying the HOA dues. So the HOA didn't have money to maintain it. So after 15, 20 years of these leaves falling and never getting removed, it just finally broke. And that's where we started seeing, there's one apartment, just really bad mold. It was just awful. It had to wear a mask through that one. But so I mean, it's maintenance. So anyway, back to ugliness, if we don't, that building is beautiful, but it still needs to be maintained. And we wanted to, and that's why we did that. We went up there and got rid of all those clogs, So finally had occupants who cared about it and started paying for it.
All right, Chris, we are at our final question. I asked this question to all of my guests. What is the one most important thing that you have learned in your career that you want the listener to take away from this conversation?
Be kind. I think that, I mean, I could leave it at that, but it's kindness in sharing, kindness in how we treat each other, obviously, kindness in our delivery, and just be thinking about, we're all people doing what we're doing. This industry is made up of people, and we're sharing. And Joe Stieberg is a great example. Matt Reisinger, a great example of how sharing can change.
You are a great example.
Thank you. But I learned from legends like them, and about sharing and about how that can move the needle to where we want it. And that to me is kindness, to say, I'm going to share this rather than I could keep it all to myself. We would not have this client in Florida if I didn't share things, because they found us through our YouTube channel, and he watched every one of them, and he said, these are the people that we want for our house. And so it's not about just getting things by being kind, but it's actually being kind to be kind. And I don't have that a-hole mentality. I don't go to a job site and I have a tough time being mean to people. And my stepfather always said, you've spent your whole life working on being kind instead of being the a-hole. So here I am. Anyway, I think it goes a long way. Be kind. Yeah.
Thank you, Chris. This has been a really, really interesting conversation. I've learned a lot.
Yeah, and it's been really fun too. And I'd love to have more conversations with you. And thank you for what you do, Jess. You're really helping this industry by moving the needle in the right direction and bringing up really hard topics to discuss, and challenging them to share and to do different, to do better. So thank you for that.
I'm just out here doing my best, just like you.
Yeah, and you're doing real good. So thanks. Yeah.
Thank you.
Great. All right, Jess.
All right, thanks, Chris. Bye. That is all for today. Thanks so much for tuning in. There will be another episode in a fortnight, so if you would like to listen into the types of conversations that I have all the time, please subscribe on your chosen platform. Rate the show, leave a comment, whatever you like, share with your friends and family. I'd love for you to spread the word about the Building Science Poddie. There's a link in the episode description where you can head to a landing page, and there are some show notes there with relevant links and a full transcript of the show as well, and also links to my socials. So if you're not already, I'd love for you to follow along there too, as I share lots of building science and building biology tips. Thanks again. I'll be back in 2 weeks, so until then, happy healthy building.